Number 9 says the diagram shows part of a curve with the equation y equals 1 over 5x minus 4 in brackets to the power a third, and the lines x is equals to 2 comma 4 and y equals 1. The curve intersects the line y equals 1 at point 11, which is shown there, and find the exact volume. Exact meaning we're not going to simplify. Exact volume of the solid generated when the shaded region, dealing with the shaded region, is rotated through 360 degrees about the x-axis. So we need to understand something about volume. Whenever we're dealing with volume, we said that we're dealing with terms in y squared or x squared. And so whenever they say the shaded region is being rotated through 360 degrees about the x-axis, it means we're going to use a term in y squared. That's what we're going to integrate, terms in y squared, because it's being rotated about the x-axis. Alright, so if they say it was rotated 360 degrees about the y-axis, would be using terms in x squared. Right, we'll be integrating terms in x squared. And because they said the shaded region is rotated through 360 about the x-axis, it means we're using x limits. So we're using x values as our limits. In this case, we have 2, 4 and 1. Right, and if you look at the shaded region, it's enclosed by y is equals to 1 and the curve, which is this equation, and this for limits. Right, so we're going to get the y squared value for this and the y squared value for this. Right, and we're going to subtract the two expressions and integrate them and use the x limits to get the following. Right, so we have y is equals to 1. So to get y squared, we square both sides. Right, so y squared is equals to 1. Right, then for our curve, it's y is equals to 1 over 5x minus 4 close bracket, then it's what is a third. Right, and if we square both sides, we have 1 squared, which is 1, so our y squared is 1 over 5x minus 4, so that will be a third times 2, which is 2 over 3. So these are the y squared values that we're going to be using. Right, and we know y is equals to 1 is right here, meaning we're going to say its value for y squared minus the value for y squared for the curve, since the curve is below. Right, so we're going to say our pi for volume, then we're going to use 1, right, from y equals 1 minus the y squared value for the curve, which is 1 over 5x minus 4 to the power 2/3. Right, that will be dx. Right, integrating this, we get pi, that will be x. Then for that, we can also take it to be 5x minus 4 to the power minus 2/3. So that will give us 5x minus 4. Then we add 1 to the power, that will give us a third, and we divide by the new power and multiply by the derivative of the bracket, which is 5. Right, and that's what we get. So let me use square brackets here, and we're going to use x values as limits, so that is 2, 4 and 1. So substituting 2, 4, maybe 2, 4 minus 5 times 2, 4 minus 4 to the power a third over 1/3 times 5, and that gives us 1/5. Then we subtract the answer we get after substituting 1. That will be 1 minus 5 minus 4, that's 1 over a third times 5. We get 2/5. So then the final answer is 1 and 1/5 minus 2/5, and that will be 4/5 pi for volume. So that's the volume generated when the shaded region is rotated through 360 degrees. And so because they said it is rotated about the x-axis, we're using terms in y squared. If they say it's being rotated in the y-axis, we use terms in x squared. And because they said it's being rotated about the x-axis, we use x limits. So we use our x values as limits, right? And usually we say the line or the curve on top subtracting the one below, right? And in this case we had y equals 1 as the line above the curve, so we got the y squared value, which was 1. That's why we said 1 minus this y squared value for the curve, since it's below, and we got 4/5 pi. And that's it for number 9.